Dear students, Assalamu alaikum. Uh, Welcome back to my channel. So today we have to solve some other questions from the Halliday, resnick and Walker's Fundamentals of Physics, chapter number 25, and we have to solve from question number 7 today. We have solved the first few questions of this exercise. Seventh problem is actually seventh problem is how many 1 microfarad capacitors must be connected in parallel to store a charge of 1 coulomb with a potential difference of 110 volt across the capacitors. So let's solve it. Actually we have to find the equivalent capacitors of the capacitors connected in parallel. So we will use the formula for the parallel combination of capacitors. So the equivalent capacitors is summation of all the capacitors from 1 to n, whatever the number of capacitors is. So if here all the capacitors have the same equal capacitance of 1 microfarad, so Ci will be equal to C1 plus C2, and there C1 is equal to C2 is equal to C3, so all of them will be equal to NC. So here the equivalent capacitor will become N into C, where N is the number of capacitance and C is the individual capacitance of each capacitor. So here C is given as 1 microfarad, and equivalent capacitors we want is equal to we know that Q is equal to CV, so C equivalent is equal to Q total charge over V. Here Q is given as 1 coulomb and V is 110 volt. So putting these things here, CQ is equal to C equivalent is equal to Q over V. Q is 1 coulomb, so put the value of 1 over 110 volt should be equal to N into individual capacitance of each capacitor. So individual capacitance is 1 microfarad, macro is 10 to the power minus 6, so it will be 1 into 10 to the power minus 6 farad. We have to find N. So we solve it. In order to find N, we make N the subject of formula. Shift this 1 into 10 to the power minus 6 here. When we shift it here, it will minus 6 will become plus 6, so it will become 1 over 110 into 1 into 10 to the power 6. It is also farad. Coulomb over volt is also farad, so farad is cancelled with farad, so we get the unitless number, which is the number of capacitors. N is equal to 1 into 10 to the power 6 divided by 110. So when we solve it, it comes out to be 9090.90, or and we can round off it to 9090, or we can write it, if you shift in scientific notation, you can write it like 9.09 into 10 to the power 3. So this is the answer to the question, answer to the problem. So we need 9.09 into 10 to the power 3, or 9090 capacitors of each of capacitance 1 microfarad to store a charge of 1 coulomb by giving a potential difference of 110 volt. So that's it. Next question is question number 9. Question number 9 is we a combination of a circuit of capacitors given. V is the voltage given here. So any voltage can be here, and we have to find the equivalent capacitance of this combination. Now look here. If we check this node, then we can have from here charge will have two ways, from one path and second in this path. So because charge have two paths or many more than one path to travel, so these two capacitors C2 and C1 are in parallel. So we can replace these two capacitors with a capacitor whose equivalent capacitor is sum of these two capacitors, because when two capacitors are in parallel, then their equivalent capacitor is their sum. So let's suppose the C12 is the equivalent capacitors of the C1 and C2. So we first find C1. Here C1 is given as 10 microfarad, C2 is 5 microfarad, and C3 is 4 microfarad. So C12, the equivalent capacitance of C1 and C2 is equal to the sum of C1 and C2, and this will be equal to, just we solve it here, C12 is equal to C1 plus C2. C1 is 10 microfarad, C2 is 5 microfarad. So C12 is equal to 15 microfarad. So these two capacitors C1 and C2 can be replaced by a single capacitor whose capacitance is 15 microfarad. Then our circuit is simplified like that. That is C3 as usual. C212 is the equivalent capacitors having equivalent capacitance of C1 and C2. So now this is the simplified circuit. This is the V here, voltage. So C12 and C3, now these two capacitors are in series. Their equivalent capacitance will be equal to, we need to find the equivalent capacitance of these two capacitors now. The equivalent capacitance of these two capacitors will be equal to the equivalent capacitance of all these three capacitors. Now these two capacitors are in series, therefore C12 is the equivalent to sum of the C1 and C2. Okay, so C1, 2 and C3 are in series, so we will use the formula for the capacitance of series, equivalent capacitance for the series capacitors. So C equivalent, the total equivalent capacitance of circuit, is equal to 1 over Ceq is equal to 1 over C12 plus 1 over C3. So 1 over Ceq, C equivalent is equal to 1 over C12. We just find it as 15, so we put it 1 over 15 plus 1 over 4. So this will be 1 over Ceq is equal to, we take the LCM of 4 and 15 is 60. 15 4s are 60, they 4 15 are 60. So 1 over C equivalent is equal to 19 over 60. When you take reciprocal of 1 over Ceq, it becomes Ceq, and reciprocal of 19 over 16 is the 16 over 9. So when you use calculator to find out 19 over 60 over 19 is 3.15789 microfarad, because these are microfarads. So it can be rounded up to 3.16 microfarad. So equivalent capacitance of this circuit, which was given initially in the question, is this circuit. So equivalent capacitance of this circuit is 3.16 microfarad. So this completes our problem number 10 also, 9 also. And next is same figure for problem number 11, and in problem number 11 is, I read it for you. Problem number 11 is this problem. In figure 25.28, the same figure I draw for you. In figure 25.28, a potential difference of V of 100 volt is applied across the capacitors. Arrangement with capacitance given as C1 as 10 microfarad, same data of the question number 9. C2 is 5 microfarad and C3 is 4 microfarad. So question is, if capacitor number 3, this capacitor, if capacitor 3 undergoes electrical breakdown means this capacitor is melt and it becomes short, and it will then behave as just a wire, then becomes a equivalent to a conducting wire. So there will be no capacitance. It means if this capacitor is removed, in other words this capacitor is removed, what is the increase in charge on C1 and the potential difference across C1? So we have to find the change in charge stored on C1. So first we find the charge in the original capacitance. Original circuit is as we solved in question number 9, same is Q is equal to, we know that Q is equal to C equivalent into V. So Q is equal to 3.16 into 10 to the minus 6. This was C equivalent, we just found it here, and into V is given as 100 volt. We multiplied it to find the 316 microcoulomb. This is the total charge stored in the circuit, total charge. Okay, so C12, because C12 and C3, be clear, C12 and C3 are in series. So Ceq is the phrase for series capacitor. There is charge on each capacitor in the series combination will be equal. So same charge will be stored here and here. So we find that C12 is equal to C12 into V12. So V12 is equal to it is the Q12 over C12, V12. We solve it, it comes out to be, put the values of Q12, V12 is equal to Q12 is 316 microcoulomb over C12 is 15 into microfarad, so minus 6 is cancelled with minus 6, and we get 316 over 15, it comes out to be 21.06 volt. So 21.06 volt is the potential drop across C12. C12 is what? C12 is equivalent capacitance of C1 and C2. They are in parallel. When the two capacitors are in parallel, then they are at the same potential difference, because this point, these two plates are at the same potential, and these two points are plates also at the same potential. So these two capacitors will have the same potential difference. So C12 is the potential difference because C2 and C1 also. So V2 and V1 are equal, and that is equal to C12, which we calculated at 21.06 volt. Okay. So Q1, now we find Q1 is equal to, we just find the formula, Q is equal to CV, so Q1 is equal to C1 into V1, so V1 is equal to V12, so we get Q1 is equal to C1 into V12, because V12 is equal to V1, because V12 is the capacitance across V1 and C1 and C2, because they are in parallel. So Q1 is equal to C1. C1 is given as 10 to 10 microfarad. This is 10 to micro mean 10 power minus 6 into V12, just calculated at 21.06. So Q1 is 210.6 microcoulomb. This is in the original circuit. If there is C3 present. Now, what comes if C3 is burnt or it is replaced? It is just removed. So we are just left with the C1 and C2. They are in parallel. Now they are in parallel. So what will be the charge on C1 now? Now see, then Q dash is the charge across new charge across the C1. So C equivalent is the 15 microfarad. C equivalent is 15 microfarad. So Q dash is equal to C1 into V1. Okay, and V1 is given as no, look here. No, but what is the problem here? This is absent, this is not present here. So V1 and C1 C2 are same potential. This is here, whatever here is potential, because between these 2 points, this point and this point is 100 volts. So they are the same potential difference. So the potential difference across the plates of C1 is 100 volt. So Q1 is equal to C1 into V1. C1 is given as 10 microfarad and V1 is now 100. So Q1 dash, now the charge stored on C1 when C3 is not present is equal to 100 into 10. It comes out to 1000. So 10 power minus 6 micro. So now the charge is 1000 microcoulomb. Initially, when C3 was present, the charge was 10.6 microcoulomb. So what is increase? Well, we just simplify, subtract it. So change in charge or increase in charge is final minus initial. Final charge is, now new charge is 1000 coulomb minus 10.6 microcoulomb. We simplify it or subtract it. It comes out to be 789.4 microcoulomb, which can be rounded up to 789 microcoulomb. So the increase in charge when C3 is removed or it is melted, then the delta Q or increase in charge across C1 is 789 microcoulomb. The B part is increase in potential. Okay, we have to find the V1 dash. Now V1 dash is 100 volt. We just found it. I discussed it, because now C3 is not present. This is not present. This is C3 is not present here. C3 is not present, so these are two in parallel. So potential difference between these 2 points is the potential difference between these plates of each capacitor. So it is 100 volt. Now the new potential difference is 100 volt. Initially, just we calculated as V12 when C3 was present, it was 210.6 volt. So the change is equal to V1 dash minus V1. So V1 dash is 100 volt minus V1 was 210.6. So the 21.06. So we subtract it, it comes out to be 78.94 or 78.9 volts. So increase in the potential difference across the plates of C1 when C3 is removed and C1 and C2 are in parallel, then it is 78.9 volts. So this completes our question number 11 also. I think that's enough for today. I stop it here. I hope you like my videos. If there is any query, you can ask me in comments. I will respond to it, inshallah. If you are new to my channel, please subscribe it and press the bell icon so that you can get all the notification of my coming videos. Thanks for watching. Keep watching Belief Physics. See you next video very soon. Until then, take care. Allah Hafiz.